Okay, so good morning or good afternoon, whichever the case may be. And so we're starting off another lesson. So hopefully you guys have been able to work your way through that page 144, 11 through 44 assignment. So what I want you guys to do now is I want you to, first on this first page, I'm going to give you an opportunity to copy everything down, but right now I just want you to put your pencils down and listen. Because the first part really isn't, I want you guys to understand kind of the history of what you're doing and understand kind of where all this comes from. So, ancient Greek guy named Euclid came up with what are called Euclid's 5 postulates. And these are the same postulates that we today use as the basis for geometry. So, Euclid started off with the belief that there was a dot, okay, and that point could be is just a location in space. Now there are an infinite number of lines that go through that point. However, if I had another point on there, there's only one line that goes through that point. Or those 2 points. Okay, so now 2 points create a line. That's one of those postulates. He then said that if there is a point not on that line, that again, there are an infinite number of lines that go through that third point, but only one of them is parallel to my first line. So those are, just so you guys know, these symbols right here, that means parallel lines. You'll see them in the book. In the book, they're actually like little filled-in triangles that are red. So they kind of look like that. And that means that those lines, if they have one little red arrow, it means they're parallel with any other one red arrow lines. If they have 2 red arrows, it means they're parallel with any 2 red arrow lines. So there's only one line going through there, okay? So those are parallel lines. Now, up until now, we've just been talking about angle pairs and angle measures. So there's no real relationship. We've just been identifying the pairs. But when we have parallel lines, something special happens. And that is now all of a sudden we have so those are our angles. Now, okay, so I know that I switched around 3, 4, 7, and 8 from how I did it yesterday, and I apologize for that, but this is how the book does it, so I want you guys to be used to seeing it this way. So, what I want you guys to do is take a second, take about 3 to 5 minutes, and I want you to write down all of the corresponding angles here. So all the corresponding pairs, write those down. Okay, so those are all the corresponding angles right there. 1 and 5, 2 and 6, 3 and 7, 4 and 8. Now remember, corresponding angles means on the same side of the transversal in a corresponding position. So that's the top left, top right, bottom left, bottom right. So 1 and 5, both top left. 2 and 6, both top right. 4 and 8, both bottom left. And 3 and 7, both bottom right. So, now what I want you to do is name the alternate interior angles. Okay? So take a second, do that, hit pause, name the alternate interior angles. And we're back. And you should get 4 and 6, and 3 and 5. Now for bell work today, you wrote down the alternate interior angle postulate and the corresponding angle postulate. So notice when I wrote down the corresponding pairs and the alternate interior angle pairs, I wrote down that 1 is congruent to 5, 2 is congruent to 6, 3 and 7, 4 and 8, and not only that, but right there, those alternate interior angles are also congruent. And here's why this is, and this is a big thing that Euclid came up with. He said that if I have two parallel lines, okay, so I'm going to let these be my two parallel lines, okay, and a transversal goes through them, okay, he said then that corresponding angles would be congruent. Now think about this. I'm going to start off with a really basic one. If this is 90 degrees right there, so if I were to sit there and say that, okay, that just here's a line and it gets intersected at 90 degrees. And then I have another line parallel to it. It should make sense to you that if it hits this one at 90 degrees, it should also hit that one at 90 degrees. Because these two lines are parallel. They go in the same direction. They always stay the exact same space apart, and they never touch. So it makes sense that if I have this other line dropping straight down right here to where it hits this first line, let's call it M at 90 degrees, that it's also going to hit the other parallel line, N, at 90 degrees. Now all we're going to do now is instead of having it at 90 degrees, I mean, technically we can still have it at 90 degrees. What we're going to do is we're going to talk about generalities. And if we write that angle there, or that transversal there, or that transversal there, that in each one of these, because M and N are parallel, you're going to end up with corresponding angles which are congruent. Now this is a postulate, okay, which means it cannot be proven. It's something we take it for granted is a bit, extreme, but it is something we just acknowledge to be true. And this has been around for thousands of years. No one's disproved it. So we acknowledge that it's true, but because we can't write a formal proof of it, we can't call it a theorem, so we call it a postulate. Okay, so hopefully that made sense. So when you have a line intersecting two parallel lines, corresponding angles are congruent. What I want you to do is take a quick second, go back to that first part, and you might want to rewrite that little section of lines and angles, the two parallel lines with the corresponding, with the transversal. So, what we're going to do now is we're going to use the corresponding angle postulate to prove the alternate interior angles theorem. So we're going to say that if A and B are parallel, then angle 4 is congruent to angle 6. Okay, so that's going to be our proof. We're going to say, given that line A is parallel to line B, prove that angle 4 is congruent to angle 6. That's kind of cool because it's only a 4-step proof. Like all good proofs, we start with line A is congruent to line B. And that's going to be given. I now put down the second step as angle 4 is congruent to angle 8. So I want you guys to take about a minute, work with your study buddy, and try and fill that in for yourself. So what you should have realized is that angle 4 and angle 8 are corresponding. And since now that we have that corresponding angles postulate, we can say that because 4 and 8 are corresponding angles on a transversal cutting across two parallel lines, that they are congruent. And that's the corresponding angles postulate. Now keep in mind this only works for parallel lines. If A and B aren't parallel, you can still have corresponding angles, they're just not going to be congruent. Step number 3. 8 is congruent to 6. Again, I want you guys to take a couple minutes, about 3-4 minutes, and I want you guys to discuss why 8 and 6 have to be congruent. I want you to think about what their relationship is, and then why that relationship mandates congruency. So we're back, and hopefully you guys came up with the vertical angles theorem. I'm going to jump a lot ahead. Don't get overwhelmed by that. It's all good. The vertical angles theorem. Now remember, vertical angles are formed when we have two sets of opposite rays. So that would be one set of rays, and then if we were to draw the opposite rays to that angle, we'd get there. And notice that the two angles we form are 8 and 6. So 8 and 6 are vertical angles. The vertical angle theorem says that all vertical angles are congruent. So there we go. So now I'm on my last step. Now this, again, I want you to take a whole 5 minutes, and I want you guys to try and fill in the last step. So one of the things that I want you guys to remember is whenever you're doing a proof, the last step should always be what you're trying to prove. So here, we're trying to prove that angle 4 is congruent to angle 6. So that should always be our last step. Okay, why is it important that that's our last step? Well, because that's what we're trying to prove. So it's silly to keep on making arguments after you've already won. And why is that? So why does 4 have to be congruent to 6? Well, let's look at the two above it. So we start off with saying that 4 is congruent to 8. Now remember that when we're talking about angles being congruent, we mean they have the same measures. So they're basically copies of the same angle. So I have this statement that 4 and 8 are the same. 8 and 6 are the same. And then I'm going to argue, well, therefore then 4 and 6 are the same. And hopefully you remember that is called the transitive property of congruency. I abbreviated that as trans for transitive property, POC for property of congruence. Okay? So make sure you have all of that down in your notes. It's important that we understand not only that we can do something, but why it's okay. So moving on. What we're going to do now is, given that A is parallel to B, I want you guys to prove that 3 and 6 are supplementary. So I'm going to go ahead and give you the first two steps. And this is a 5-step proof. So I want you guys to take about the next 5-10 minutes, and I don't know exactly where we're going to be at time-wise in class right now, and try and fill out the rest of this proof. I want to be able to prove that 3 and 6 are supplementary. That means they add up to 180 degrees. Go. So go ahead, hit pause, come back when you're ready. So we're trying to figure out and prove that 3 and 6 are supplementary. And the only fact that we're given is that A and B are parallel. So we start off with the fact that A and B are parallel. That's given. And then we can use the corresponding angles postulate to say that 3 and 7 are congruent. Because we know that when two parallel lines are crossed by a transversal, corresponding angles are congruent. It's the corresponding angles postulate. So, our next step. So what do we want to do is so now we have 3 and 7 together. So now what we want to do is we want to combine or at least relate 7 and 6. So we go 6 and 7 are supplement. Whoa! We go 6 and 7 are add up to 180 degrees because there it's a linear pair postulate. We see that 6 and 7 right here are linear pairs. We know from the linear pair postulate that linear pairs are all supplementary. We know that supplementary angles means that their measures add up to 180. So if 6 plus 7 equals 180, we can also say that 3 plus 7 equals 180. Now all I did there was switch out the measure of angle 6 for the measure of angle 3, and that's substitution. And then, so finally, so we know that 6 plus 7 equals 180, 3 plus 7 equals 180, or 3 plus 6 equals 180, sorry. So I didn't say that 3 and 7 are supplementary. Now remember, that is from the definition of supplementary angles. And it's 3 and 6 are supplementary. Because we know that when two angles add up to 180 degrees, they're supplementary angles. So because 3 and 6 add up to 180 degrees, they must be supplementary. Now for those of you who prefer paragraph proofs, that's on the left-hand side. So take a break, write all this down, make sure you have it in your notes. So this last page, what I want to do is apparently give you guys a headache. I want to go through the different symbols. So at the bottom we have the two squiggly lines together, and that means about. That's like an estimate. So for that, an example would be pi is about 3.14. We all know that pi goes on infinitely. I think you guys actually watched a video on that. But we know that it is about 3.14, and that's what most people actually refer to it as. Going up, we then have similar. Now, similar we'll get into a lot later in this year when we deal with, well, similarity, but that's not something we deal with now. Now, up above, the last two are equal signs and the congruent sign. Now, the equal sign deals with numbers, okay? So, 4 is equal to 4. Congruency relates shapes together. So, two angles are congruent, meaning that I could overlay the angles on top of each other, they'd match up perfectly. And if they are congruent, that means their measures are equal. So the numbers are equal, the shapes are congruent. So if you guys still have time on this, what I want you guys to do is look at page 153, 12 through 17, and use that as classwork. If we don't have time for that today, we'll go ahead and do that first thing tomorrow. Hope this made sense. Might have to watch it a couple times. But really the key here is identifying the relationships between those angle pairs, identifying corresponding angles, identifying alternate interior angles, identifying alternate exterior angles, and identifying same side interior angles, and knowing that each one of those angle pairs has a special relationship. Specifically when they are formed by a transversal cutting across two parallel lines. If they are corresponding angles formed by a transversal cutting across two parallel lines, they are congruent. If they are alternate interior angles formed by a transversal cutting across two parallel lines, they are also congruent. Now, if they're same-side interior angles formed by a transversal cutting across two parallel lines, then they are supplementary. That means they add up to 180 degrees. But if they are alternate exterior angles formed by the intersection of a transversal and two parallel lines, then they are congruent. So 3 of them are congruent, 1 is supplementary. And if you can identify those angles pairs as corresponding alternate interior, alternate exterior, or same side interior, you're like 90% of the way there. Because then you can just set it up as either equal to each other or adding up to 180, and then you can just math your way out of it. Thank you guys very much, and I hope this made sense.